What if AI created real value for your business, for your people, for you? What if you were truly empowered to cut your lead times in half, empowered to prepare twice as many quotes with the same resources, empowered to enter new markets at 1/3 the cost? Epicor Prism is made with and for makers, movers, and sellers, and it is making business better for Madsen Custom Cabinets, who says, "We're excited for Epicor Prism to help take off the load of mundane tasks so our staff can focus on the stuff that's producing value." What can Epicor Prism do for you? Take a look. The user asks Epicor Prism, "Get me a list of RMAs." Instantly, Epicor Prism processes the request and displays an interactive grid of open return merchandise authorizations. The user can easily sort, filter, and interact with the data directly from the grid view. The user spots a metric on the screen and asks Epicor Prism, "What % of receipts are late?" Epicor Prism instantly interprets the data and provides a clear response, giving the percentage directly in the chat. Rather than creating a new metric or pulling out a calculator, users can simply ask a question and get the answer immediately. In a world powered by Epicor Prism, every day is efficient. Every day is full of opportunity. Every day is easier with Epicor.
All right, hello and welcome to a brand new event from Metal Forming Magazine and the Precision Metal Forming Association. This is our first ever Metal Fabrication Strategy Summit, and we're happy that you're here to be with us today. I'm Brad Kubin. I'm the editorial director of Metal Forming Magazine, a publication of the Precision Metal Forming Association. And I'm very pleased and excited to welcome you to day one of what is our 3-day webinar series. This event is unlike any other that we've produced in the past, in that while we do have 2 expert keynotes on the agenda, the main event, if you will, is a series of 6 panel discussions that will play out over the next 3 days. These are facilitated discussions with expert panelists from the metal fabrication industry, and they'll be covering a variety of critical topics. Before we get started on today's program with our opening keynote, just a few notes about today's Zoom meeting. This meeting is being recorded for archiving, so the recorded event will be posted to our website within the next few days. You will receive an email from us when that recording is available to view online, and you'll be able to watch it again, share it with others at your company. Also, all the participants in the meeting are in listen-only mode, so our speakers and listeners will not be able to hear any audio from your site during the program, but you can, of course, communicate with us throughout the program by submitting any comments or questions. You'll use the Q&A link. Don't use the chat window. Please use the Q&A link to talk to us. That's located on the bottom of your Zoom screen. Questions will be addressed as time allows for at the end of the presentations. And please, we always want you to ask questions of our speakers and panelists. We want this to be interactive. The panelists, of course, want to hear what your concerns and questions are. And we'll be happy to address them. So without further ado, it is my pleasure to welcome our opening keynote. He's going to help set the table really for the upcoming panel discussions throughout the next few days. Our first keynote speaker this morning is Clark Dressen. Clark is the Chief Technology Officer of MXD, the Digital Manufacturing and Cybersecurity Institute, which is based up in Chicago. Clark's in Texas. So among his responsibilities at MXD, Clark supports the U.S. Department of Defense and a nearly 300-member ecosystem to drive economic prosperity and support national security by increasing U.S. manufacturing competitiveness and preparing the workforce for the advanced manufacturing jobs of the future. As you can see on your screen, Clark's talk today is going to introduce MXD's vision, his vision for the digital factory of the future, where AI, cybersecurity, data-driven decision-making, and advanced automation converge to redefine manufacturing. So please welcome Clark Dressen.
Hey, thank you so much, Brad. Can you hear me okay, by the way? Want to make sure coming across?
Sounds perfect. Yep. Thank you.
Beautiful. Okay. Excellent. Well, first off, really like to thank Metal Forming Magazine and the Precision Metal Forming Association for organizing this event and providing me this opportunity to share a little bit about MXD with you. Unfortunately, our CEO, Bernardino Barada, was going to speak. He had a last minute conflict and actually really interesting opportunity that we're pursuing. So he's not going to be able to present. So he asked me to step in. My background, I have 36 years of experience with Dow Chemical, all in industrial IT, so manufacturing, applying IT tools in there. I retired, took about a year off, and then was ready to kind of keep working. So Bernardino talked me into being a CTO for MXD, and I'm really enjoying myself. And you'll see why as we get into the content. Today, I'm going to share a little bit more about MXD, who we are, what we do, and then provide some insights into some of our projects to highlight how digital tools in cybersecurity, but how that really impacts the factory of the future, and really the factory of today, right? The fact of digital manufacturing today. So with that, let me press on in. So what is MXD, right? MXD is the second oldest of 18 manufacturing USA initiatives, institutes. And so MXD is 11 years old, a little over 11 years old. Each of these institutes is a public-private partnership focused on different yet very specific areas of advanced manufacturing, from lightweight metals to biopharmaceuticals to robotics. You can see the collection of the different institutes on there. 9 of those, including MXD, are partnered with the Department of War, formerly known as Department of Defense. 7 of these are partnered with Department of Energy, and 2 of these are partnered with the Department of Commerce through NIST. So while we are independent, there is a lot of collaboration and partnership amongst those as well. And really, although each one's unique, we all share the common mission, and that is strengthening the U.S. manufacturing industry. So very targeted on manufacturing, very targeted on the United States, and uplifting companies not only to help the defense industrial base, but really to enable and empower the entire industrial base in the United States. So MXD, cool logo, right? But what does it stand for? It means manufacturing times digital. And so I mentioned some of the other focus areas for the other institutes. MXD's target, we are the nation's digital manufacturing and cybersecurity institute. So we're the only institute that actually has 2 different missions, being digital tools and then the cybersecurity side of things. So the real mission statement is MXD strengthens national security and economic prosperity by increasing U.S. manufacturing competitiveness through the adoption of digital manufacturing tools and technology. So in partnership with that Department of War, we convene an ecosystem, and I'll talk about what that ecosystem looks like in a minute, but we convene that ecosystem to solve critical manufacturing challenges. So we're looking for the hard things to do. We're looking for the gaps, and finding technology to resolve those gaps. We want to empower a skilled workforce, build skill sets, culture, all those type of things. Then obviously modernize manufacturing supply chains. The center itself is based in Chicago, and we have a 74,000 square foot facility there. And probably the highlight of that, there's a 22,000 square foot factory floor. Factory floor is part showcase, it's part test bed, it's part training and education space. But we have over 10,000 visitors a year experience how advanced manufacturing can improve factory operations and drive business success. We have great meeting spaces to convene folks to come in and talk about common topics, whether they're AR, VR, or cybersecurity, or quantum computing, or whatever the topic is that we need to cover. Great facility, and if you find yourself in the Chicago area, please come by and visit. It's a fantastic way to spend an afternoon. So we talked about the mission, and like I said, for about 11 years, we've delivered this mission by convening that industrial base. So really bringing together our partners to identify and solve the top challenges that manufacturers face in modernizing and securing their operations. We also focus on technology. So we advance technology, innovation, and adoption to deliver resilient and revitalized supply chains. And so this includes, you know, technology projects. We look for opportunities to bring our partners together to create solutions. And at the end of this presentation, I'll actually give you some examples where we've done that. But bringing together solutions to address the problems that were identified. And finally, and you guys probably know this, it's not a surprise to anybody. Um, Technology by itself is worthless, right? Unless you go drive adoption and drive the culture changes needed to do that. So we have an empowering part of our mission that talks about skill development, talks about culture development, training, all the things we need to build the skills necessary to drive the needs of being able to adopt and implement these technologies. All right, so what does our network look like? Yeah, we don't do this alone. We can't, right? The MXD is actually a small company, about 50 employees, and our entire mission is to bring these organizations together to solve these problems. So we have over 360 members in our network. You can see from the slide there, 23 of those are or what we consider top tier, and I'll talk through that. 30% of that organization are actually manufacturers, and we're growing our small and mediums. But the network itself is made up of obviously Department of War personnel who are guiding us and helping us shape. The defense industrial base does a lot of their own manufacturing, right? Whether it's an Army base building energetics, bombs and things that explode, or the Navy building boats and submarines, Air Force, etc. So in addition to that Department of War, the network includes large and small manufacturers. And these are, defense, obviously, but also oil and gas and chemicals, food and beverage, pharma. We have a lot of manufacturers part of that network across all industries. It includes solution providers of all types, so service, selling technology, those type of things. Academics, universities and research institutions, and also other nonprofits that have complementary missions. And we need all those to really be able to execute our mission. So who are some of the top tier members? You'll see we have 23 top tier members. That includes 4 of the 5 top defense suppliers. So you see Boeing and Northrop Grumman and Rolls and RTX, all 4 of the top 5 OEMs in terms of defense suppliers. But you also see again, Dow and Siemens and DMG Mori and Abbott. So again, you see across that manufacturing and supplier network, right, of being able to bring those together. And these companies have a tremendous value, right? I mean, they obviously get a lot out of this, and they bring things to the table. And again, you can see our tier 2. We've got a great collection of service providers and other manufacturers. But I think one of the main reasons that we see the top tier members continue to join is they actually also get access to our list of tier 3 members. And I am by no means going to read through this slide, but we have a very rich community of tier 3 members. And you can see small and mid-sized manufacturers and solution providers and academic institutions. And so to me, this really is the heart of the U.S. manufacturing industry, and we'll talk a little bit more about what some of the challenges are there. But these partners, like I said, are really helping drive the problem spaces, the gaps, and really helping us find those opportunities we can go apply digital technologies in. So one quick side note, a little bit of a commercial here. I don't know how many folks on the phone are actually representing a small to medium-sized company. But we recognize, the large companies obviously have pretty big staffs, right? Focused on innovation, focused on technology, cybersecurity. It's when you get to the smaller companies that it's a challenge, right? You're busy making stuff. You don't have dedicated people maybe necessarily focused on this. So we want to point out a small and medium manufacturer can actually join MXD for free. There's a sign up process. they actually ask you to do a technology evaluation or a readiness assessment that actually helps us feed our problem solving space. But if you are a small medium manufacturer listening to this presentation and you're seeing some value in, hey, I can actually go access some of these cybersecurity best practices or digital manufacturing best practices, and you're interested, please reach out, and we would love to have you join our network and become part of that tier 3 membership. And it is free, other than the time to do the survey. So let's talk about manufacturing. So I think the latest estimate was over 240,000 separate manufacturers, and I think 4,000 of those are considered large, right? 4177 on the list there on the right side, large manufacturers, and that's considered more than 500 employees. So when you think about what's left, right, the in between 500 and less than 20, the largest number of manufacturers are actually the small and mediums. So I think that's like 98% of the total. So 75% of all the manufacturers you see on that list have fewer than 20 employees. So manufacturing in the US gets very small very fast. And again, to all of you in the audience who are listening and you fit into that small to medium sized manufacturer, thank you. I mean, you guys are the heartbeat. You're the foundation of what US manufacturing is all about, is providing tools, providing equipment and product into that supply chain that then get deployed into the larger manufacturers. I'm learning a lot, right, with working with the big OEMs, the defense OEMs. They can't survive without their tier 2, tier 3, tier 4 manufacturers that are providing that, that small little part that makes an aircraft fly, or that small little part that makes a tank float. So just thank you. It's a key part. So as a Department of War sponsored institute, we're also tracking through the entire defense industrial base. And that's a subset of this overall industrial base, right? I think there's still about 60,000 manufacturers that really fit the defense manufacturing side of things. And even in that 60,000 manufacturers, it's a similar distribution. So we recognize the challenges, we recognize the opportunity to really go position that for success. So with the thoughts that, a resilient manufacturing base being critical to economic prosperity and national security, you think about what does manufacturing do for the United States? And the thing I love, manufacturing is consistent. Doesn't matter which political party is in power. It doesn't matter, what's happening in the world. We've got to make things, right? And you're seeing that emphasis right now on, hey, we've got to bring manufacturing back to the United States, and that's, again, that's great for all of us that are manufacturers. We'd love to see that focus. Manufacturing still contributes 10 cents to every dollar of GDP. It employs nearly 13 million people and provides a lot of good paying jobs, right, for U.S. citizens. It is the main economic engine for the country. And it's a primary employer in about 500 U.S. counties. I think there's like 3,100 counties total, but in over 500 counties, manufacturing is the primary driver. So it is, it's a pathway to middle class for many, many Americans, right? They depend on that income, they depend on that stability, and again, keeping manufacturing effective and competitive is one of the key things we're focused about. So the progress that we make in addressing the challenges that we see, the gaps, is critical. And again, given how important manufacturing is to the United States. So just to wrap this one up, if you take nothing else, that resilient manufacturing base, it's all about the country's prosperity, it's about the citizens' prosperity, and it's about national security. Very, very critical. So let's talk about some of the challenges. What's happening in the industrial base, right? Between 2010 and 2020, the number of manufacturers in the country actually went down by 20,000 manufacturers. And nearly all of those losses were small manufacturers, small and mediums. So that's a bit scary. That's 11% of that lost in the last 10 years. In 2021, Manufacturing surpassed all other sectors as the most cyber attacked industry globally, a trend that's continuing. And we know, you see all types of focus on IT, enterprise IT and mail, and the threats that come across there. But the OT, the operational technology of how we run those manufacturing plants, it's a target, and we've got to continue to double down and make sure that we are just as secure on the operational side of things as we are on the IT side of things. And the number of unfilled jobs in manufacturing is close to 500,000 today, and it's projected to rise by nearly 2 million by 2030. And that's because of a retirement projection and an aging industrial population and everything else. So we do have some pretty key challenges that we've got to continue to try and address. All right, so let's talk about advanced manufacturing related to technology, related to digital transformation. So advanced manufacturing, whether you're doing additive manufacturing, 3D printing, to AI-driven factories, to metal forming, and using robotics and data to streamline those processes. Those tools, advanced manufacturing is really revolutionizing industry. It's driving innovation, it's driving productivity gains, but all of that relies on a strong and secure digital foundation. So generating and aggregating data throughout the manufacturing life cycle to make that informed decisions and improve operations. An end-to-end, top-to-bottom approach to really design to production and sustainment, and integrate the entire supply chain from those largest suppliers to our smallest suppliers, so you have visibility and reliability of supply chain and product security and all those type of things. And data security. So making sure that we don't put our nation's assets at risk. A lot of our manufacturing data is intellectual property, right? So how we manufacture the assets that we manufacture with, those are intellectual property, and we've got to make sure that we lay the foundation, and we get the data, and we get the networking, and we get the transparency of information from the shop floor to the top floor and to the operators. But we've got to do it securely, and we've got to do it reliably. So cybersecurity and digital transformation, they've got to go hand in hand in order to protect our supply chains from threats, while we continue to uplift their capabilities through that digital adoption. And so, as an example of how MXD is working to apply technology in these spaces, we've actually, over the 11 years, we've executed over 200 different projects in these areas. So that includes accelerating adoption of model-based engineering, using AI to make informed design decisions, and I'll show you some examples of these here in a little bit with the project slides. Using AI and digital twins to eliminate the supply chain to predict and mitigate risk events, and using vision, IoT, and AI to reduce fatigue-related injuries. Right, fatigue. The number is just astounding. Well, I think it's millions of dollars per week. I think tens of $millions per week. They estimate that fatigue costs manufacturers. And again, MXD is focused on solving those problems that manufacturers face based on this. So let's talk about large manufacturing. We know, again, those tier one companies that I listed, I was with Dow Chemical for 36 years. We certainly fit that criteria. Large manufacturers understand the value of advanced manufacturing, and they're absolutely investing in digital transformation, right? So you can see this slide just talks about where they're investing. So factory automation, data analytics, production scheduling, sensors, cloud, all those great things, right? All part of advanced manufacturing. And you're seeing that 75% increase of what they expect the budget to be on that left-hand side. So that's great. I love to see the large manufacturers investing. It's focused on the core technologies that are going to really drive that digital transformation, but they're also realizing they cannot achieve the full benefits of a digital transformation until that entire supply chain forms. And so we recognize this is great. A Rolls-Royce or a Dow Chemical or a Boeing, right, can go spend as much as they want in digital transformation and cybersecurity, but they need that support of the larger network. All right, so based on that, you know, we're working with our partners to really go prioritize and focus in on what are the most important technologies. And you'll see some things that seem like pretty basic blocking and tackling, right? Sensors, data analytics, cloud computing up on that right-hand side. But again, when you think about that, again, maybe our large manufacturers have done some things there, but as you dribble down into the small and mediums where you say, hey, if I've got a company of 25 people and those 25 people are focused on keeping the shop floor running and scheduling jobs and getting product out the door, you probably don't have somebody whose full-time job it is to think about how to go apply edge computing or robotics or anything else. So again, it goes back to speak to how can we take these technologies, lay that foundation, and prioritize the ones that are going to have the most impact into our manufacturing base. And so that's where we're spending quite a bit of our time. All right. So what are some of the barriers to digital transformation for those small and mediums? So again, we talked about small and mediums make up about 98% of manufacturing, and they're a critical part of that large manufacturer supply chain. And so when you look at the slide, it's interesting. You say, hey, money is absolutely a gating factor, but it's not the only one. It's not even the most important one, right? A lot of it is just the time, the time to go execute, the shortage of the digital skills and the talent, the culture, right? Embedding this into your work process and managing those work process changes to not only deliver the technology, but get employees to embrace the technology. And I'll give you one example. When I was working with Dow, we introduced an AI project. It was a fascinating project. It was in our ethylene crackers, one of our biggest assets in the company, and it was focused on reliability. And what I found fascinating is that when we even started to introduce that, the reliability organization said, we've been running these things for 50 years. Who's going to know how to run these things better than us? But by demonstrating some of these AI tools, they started to buy in, and then they became champions to go help drive that transformation, help go drive that adoption. But it's fascinating because it's not necessarily obvious that we need to go do this. But once you start, then you get that buy-in and you get that partnership with your operations and your maintenance teams and really start to get the changes that you need to make this successful. So if you're a large manufacturer and you're not talking to your suppliers about how they're driving manufacturing adoption, you probably need to start. And if you're a small manufacturer, look for the opportunities like MXD where you have free resources that can help you go drive through this, right? So all right, so in the last few slides I'm going to talk about today, I'm going to cover a few examples of projects. I can't cover them all, obviously, so I'm going to cover a few that I thought best fit what we're talking about today. So this is one example, and again on some of these slides you'll see an example of how MXD operates. So on the bottom left-hand side, you'll see this was a project we actually partnered with Raytheon, with ITI, and Microsoft. And so Raytheon was the primary driver from a manufacturing standpoint of view. And they said, hey, we've got this problem. We've got production issues that pop up because there was a design time decision. So during design, something happened and something got designed poorly. They caused an issue production. We won't ask if anybody else has seen that. We'll probably have a lot of hands up, right? But it's a universal problem that happens in all industries and manufacturing processes, right? We have very experienced designers in a lot of cases that have the knowledge. They've made the mistakes. They've learned to fix them. They know how to avoid them. But by the same time, 25% of the workforce is expected to retire in the next decade. So you've got new designers. You've got folks that have never learned from that knowledge. So how do you start to incorporate that? How do you capture that such that you don't have to make those same mistakes over and over and over again? So this particular project, CODA, was a project that tried to do that for printed circuit boards. And I know that's different than metal forming, but it's a similar idea that they had a manufacturing process. Those design changes cause problems in the design production down the road. So they applied some AI tools to look at past designs and help educate designers in the front end when they're making decisions, and educate them on what those downstream effects could be. So this one was adopted. It was implemented. They built the culture around it, and was really considered a strong success by the company. Another good example, and I think I really like to tell this story. This is just over the last few years. This story and the next one both start to talk about some work we did with the Defense Industrial Base. And so this one is the Portsmouth Naval Shipyard. So we spent a lot of time partnering and going to listen to our Department of War counterparts. A lot of these are obviously brownfield facilities. They're old legacy sites with old legacy equipment. And you start talking about digital transformation. You're not just going to go toss out perfectly functional equipment just so you can replace it with equipment that's digitally enabled or smart, right? Yeah, that makes no sense. So a lot of our defense industrial base, they don't think they can benefit from digital, and it's been a lot of work to educate and to embed some of these ideas into how to change those work processes. So another common challenge is, well, we just don't have enough skilled labor to accomplish all the work we need to do to do that transformation. So we sat down with Portsmouth Naval Shipyard. So it's a good example of how we took a legacy site. They had a workforce challenge, especially in the maintenance, repair, and overhaul of ships. So we sat down with their machine shop, and we started talking through what that MRO process looks like. And one of the biggest issues they had was they've got, again, this legacy equipment. So they had scheduling issues. They had machine downtime. They had reliability problems with a lot of their legacy equipment. And so we sat down and we started talking about, hey, we could take this concept of a sensor kit, give you some basic data to drive decision making, right? Make that data available, whether it's temperatures or vibration or understanding their equipment, understanding their problems, but just providing some basic sensor data. And I know this seems, especially for digital transformation, it seems like basic blocking and tackling, and it really is. But it was groundbreaking because this was this legacy equipment that had never been done before. So we took some sensor kits. We actually developed some basic sensor kits on our own, brought them in, and for the first time allowed them to use some data analytics to improve the scheduling, reduce machine downtime, and drive throughput and innovate and utilization. The impact was significant and provided an immediate ROI. You can see a nice little quote from one of the folks there on site. And shop workforce has been very effective thanks to that. So quick talk about what the sensor kit is, right? The technology doesn't have to be, all that challenging or even expensive. The sensor kit, you can see a picture of it up in the right-hand side, was basically a really simple interface to where we said, hey, let's make sure we can get some basic, temperature, vibration, current draw, viscosity, whatever the need was, right? A very basic sensor kit. It's got 4 analog inputs, 4 digital inputs, nothing fancy, right? But the ability to start collecting some of that data, maybe put up something really simple like a stack light, right? Red, yellow, green of if you start to get outside of a specific characteristic. But it's a self-contained compute device that can gather and analyze that data in real time from manufacturing equipment. So it's a real closed loop approach. It's secure, which had to be, obviously being a DOW site, and it's really focused on the solutions that they were having on site, and getting the visibility and the data to the operator to support that digital adoption. So I've got one more example that uses that same sensor kit, but it takes it one step further. So we built on that success, and we started working with Picatinny Arsenal. And Picatinny is interesting because they do manufacture energetics, right? So they are one of the places that manufactures TNT. So these are critical to munitions, critical to bombs, right? Those explosives. And so in partnering with Picatinny, they came back and they said, hey, we would really like to build a digital twin of our entire facility. And we started talking to him. We said, well, you can do that. It's going to be very expensive, right? You don't have the data. It's going to just it was a request without a lot of meat behind it. So they take a life of their own sometimes, right? So we started to partner with them and said, hey, there's a lot of reasons that starting with a digital twin of your entire facility may not be completely accurate. How about we start with one process? And so we focused on the TNT melt pour process. It's a critical element of the manufacture of explosives. It takes a lot of solids and liquids. You're mixing them together, and the process today took a lot of experienced operators, right, who knew just how to get it just right. Hey, it needs a little bit longer. Sight, sense, smell, touch, right? How do you know when that point is just right, when the melt pour process is good and your TNT is now effective? So we modeled through this and said, hey, a digital twin would absolutely provide the right real-time monitoring of the process, no matter who was operating the equipment, right? An experienced operator, younger operator. But given this was a U.S. Army project that involved explosives, the expectation was, wow, if we just put this out as build a digital twin for a bomb making process, it was going to be extremely expensive. A, you've got the government tag, and everybody's going to triple their bids, and B, it's explosives, and people are nervous about that. So we put out a bid, partnering with them, and said, hey, we have a partner who is in the food and beverage industry, and they want to manufacture cakes. And it turns out cakes are a lot like making TNT, right? You add the dry, you add the wet, you mix them together. You're measuring conditions throughout that process. And by doing that, we were able to find a vendor that was interested in bidding. It was actually using a digital twin that supports food and beverage today. And we were able to get that process in place and build a digital twin to model what that melt pour process looks like. And now they're working to embed that into their process. And again, that idea of a golden batch about hey, how does a younger operator be able to manage through that and make sure that you're within the right operating conditions so that you don't have bad batches, better safety, better efficiency, better productivity and throughput. So just again, a fascinating use of the technology to solve some of those real world problems that they have. A couple more projects just to highlight. Predictive analytics, right? Enabling supply chain visibility was another project that we sponsored. This one was all around thinking about providing visibility and part flow across large supply chain networks. So, obviously, inventory managers rely on delivery dates for maintaining part stock. This particular project helped provide more accurate and reliable estimates on delivery dates across a broad vendor base, getting customized information on supplier details, and really reducing inventory costs while making sure you met those delivery schedules. And this is actually just one of 30 plus projects that we've executed focused specifically on supply chain and making that data available to drive more informed decisions across the supply chain. So this is a key area of focus as we go forward. All right, on cybersecurity, we talked a little bit about it, but we know the cyber threat is real, right? So the OT factory floor is a challenge, right? We know that large manufacturers may have staffs focused on this, but again, small and mediums can struggle to really understand and know what they need to do in the cyberspace. So we want to highlight that more and more digital data is being driven through that supply chain, and that that threat, they'll go after the weakest link in the supply chain, and I do think that means a lot of the SMMs are at high risk because it's such a critical space for that risk of attack. So one example, you think through what the Department of War is doing. They are implementing a tool called CMMC. It's a cybersecurity maturity model. It's a certification. There's a lot of companies that are in process of getting approved and getting audited for the CMC compliance that allows you to do business with the government. But this is one example where one of our partners, Rolls-Royce, came through and said, hey, look, yeah, we're very comfortable. We're Rolls-Royce. We've got a great cybersecurity organization that's focused on our data. However, we think that there's a big opportunity for our tier 2, tier 3, and tier 4 members to strengthen their cybersecurity. Could you go put together a program? So we went and got funding from the Department of War to help support that, and we created a entire program on delivering cybersecurity information to the tier 2, tier 3, tier 4 suppliers from Rolls to help with best practices, training, just workshops, all those types of things to really build awareness and support of cybersecurity. It went so well, we then rolled that out to Oshkosh, Boeing, DMG Mori, right? And we're talking with other suppliers as well about extending that. I think we've touched over 20,000 suppliers across those 4 companies. Some of you on the phone may be part of that. Maybe if you do business with one of those members, you may have already seen some of this information. But if you're not in the program and are interested, I do want to point out that we have a cyber resource hub. And again, this is part of what you get access to if you decide to become a member, whether you're preparing for CMC compliance or just want to improve your overall cyber posture. This cyber hub is either free or low cost information if you're a member. So again, another plug for joining the MXD if you're interested. I'm running short on time. I want to get to questions, so I'm going to skip this one. It's in the slide deck if you would like. And I'm just going to touch on one last topic, which is training. So we are hard at work in providing resources and training information to employers and employees. We developed 4 workforce readiness guides, and they are focused on key digital and cybersecurity skills for over 750 different roles in manufacturing. And those guides are free. They are available. They're part of that network. Again, if you're a partner, you have access to those, and you can use them for writing job descriptions, hiring, you can use them for industry recognized certification training, all those type of things to go forward. So that is absolutely available. Anyone can engage with the courses. We have an MXD Learning Training Center. There's thousands of free and paid courses that are available from MXD and other third parties, and users can move through those at their own pace. I think there's 300,000 individuals that have already engaged in some of these workforce programs. So it's available and good practice. So with that, let me wrap up with this last slide of just thank you for attending today. I hope this gave you a taste of how digital transformation is really impacting manufacturing. If you're in Chicago, please come see us. We can show you around the factory floor, that 22,000 foot showcase, to show you how to put these advanced manufacturing concepts in place and in practice. And I want to thank you for your time. Thank you again to Metal Forming Magazine and Precision Metal Forming Association for this opportunity. I'm going to turn it back over to Brad, and we'll see if we have any questions and answers.
Clark, thank you so much. Really, really great presentation. A lot going on there at MXD. It's exciting. I'm just learning about it myself, really, what you guys are all up to. I hope our audience found it interesting. We have a couple minutes for questions, and then we'll launch into our first panel discussion. And really, this first question from the audience, Clark, is really just a broad-based general. What is your opinion, your perspective on how the work that you're doing and how, as this technology gets implemented within U.S. manufacturers, how does this help ultimately bring back manufacturing to the United States, making us more competitive in the global marketplace?
Sure, and that's a great question. And I do think that it's a lot of the reason I came out of retirement. I like this stuff, right? And I think the digital transformation aspects of what can it mean to manufacturing, like anything else, if you pick your iPhone, pick whatever technology you want to pick, if there's not a good use case and a good value case for the technology, then there's really no point in doing it, right? And so you start to think about, all the use cases that we have in manufacturing. And when we go, I led an innovation team in Dow. That was the last 5 years I had with Dow. And to me, it was fascinating because you'd go and you could say, hey, we found this great robot. And you'd get very little traction. But when you had somebody that said, hey, we do, we do inspections of confined space entry. Are there any digital tools that can help us solve that? Oh, well, yeah, we have a robot that can do, so to me, it was all about finding the opportunity and the gap. So what are the problems? So we have safety issues, right? Whether it's confined space entry was a great one. People working at heights, people, fatigue and all those different type of things working around repetitive motion or machinery, heavy machinery. So safety is one. Quality, right? So fewer bad batches, fewer off spec product, fewer mistakes by human error, all those type of things. Efficiency, productivity. So finding those use cases will make U.S. manufacturing more competitive. It will make us safer. It will make us more able to compete and leapfrog, hopefully, whether it's China, Europe, whoever, right? That we're competing with. And again, doesn't even matter industry. Those use cases apply to every industry: oil and gas, chemicals, pharma, food and bev. It's all the same.
Yep. Great. I was interested personally to hear that you've had 300,000 people involved in your training at one point or another.
Yeah.
That's a huge number. Are those mostly with the bigger members, I would imagine?
Some, although there's a lot of programs that are just out there and available that, and again, that Learn, the MXD Learn Virtual Training Center. It's a lot of people sign up, and then it's not just MXD courses. There's other third parties that provide content as well. So it's a great starting point just to get access to information.
What are some of the key technologies that you see people being trained on to prepare for this digital manufacturing?
Sure. Yeah, I think say the two biggest ones that seem to be attractive. One is, of course, the cyber. Everybody's concerned about cyber, so you see a lot of folks on that. The other one is data. I'm surprised at how many people. So from a data integration, and it makes sense, right? It really is the foundation of a lot of the things we do for digital man. You can't do AI without data. You can't do analytics without data. You can't, so I do see a lot of people, it looks like, starting to say, how do I get that foundation that I can be prepared to go drive those more advanced use cases? Those seem to be the two top ones that get attention.
Excellent. All right, well, Clark, again, thank you so much for the really excellent and thought-provoking presentation. Thank you for stepping in at the last minute. I know.
Happy to do it.
Just called in. So again, thank you for being here. I hope everybody enjoyed that conversation. I know I'm going to try to make sure I visit MXD next time I'm in Chicago at this
great facility. It's right on Goose Island, and right next to the Goose Island Brewery, actually. So you can get a good beer smell.
That's wonderful. All right, thank you, Clark, again.
Thanks so much. You guys have a great rest of your session.
Appreciate it. All right, so now we're going to go ahead and jump into our first panel discussion, the first of six. This first session's on the topic of design for manufacturing. And for that, I'm going to go ahead and turn things over to our panel and our facilitator, Metal Forming Magazine contributing editor, Kate Bachman. So Kate, take it away.
All right. Hi, everyone. Thank you, Brad. I appreciate that. And hello, everybody. Welcome to our session, Design for Manufacture. Your clients are experts in the products they produce and sell. They know well how those parts and assemblies are intended to function, but they may not be as well versed into the optimal way to manufacture them. And that's where your expertise comes in. Leaning on your years of manufacturing and deep knowledge of fabrication processes, you can suggest changes that will make the manufacture of those fabrications more manufacturable, eliminate flaws, operations hang-ups, and pave the way to make the manufacture of them run smoothly. Often, the suggestions you make for changes will save your clients costs. In this session, we'll delve into the whys and hows of successful design for manufacturing and how to establish partnerships with customers to ease the process. I'm delighted to introduce my panel of fabricators, and if everybody would go ahead and join my camera. Thank you very much. Jeff Deck is here. He's the president of Leistra Manufacturing. Hi, Jeff. Russell Hillenberg is the president of Woven Metal Products. Hi, Russell. Ed Frymouth is principal of Versatility Tool and Manufacture. And I don't see Ed here yet, but he'll be joining us shortly, I'm sure. And then Kevin Connery is the assistant engineering manager and die designer for Rockford Toolcraft. Hi, everyone. Thank you so much.
Hello.
So before we kind of delve into the main topic and start with the questions, can you just each take about a minute or so to tell us a little bit about your company and what you manufacture? And we'll start with you, Jeff.
Good morning,
If you-
everyone.
There you go. Thank you.
Yep. Leistra Manufacturing is a family-owned business, been around since the early 50s. We're a contract manufacturer, so we have a lot of different products that flow through our facility over the years. And I'm actually listed now as the former president, just retired. But we are very highly experienced in metal fabrication as well as design for manufacturing, or otherwise known as VAVE, ESI for early supplier involvement. There's a lot of different terms for that. And Kate's right. The best time to get involved is your customer. They know their product, but we know the metal side.
So Jeff, just a note about your retirement. First of all, thank you for all your years of service. I know you were involved with PMA for many, many years and many capacities. We appreciate that. And as I understand it, retired means you're just tired again. Is that right?
Yes.
All right. So we'll move on to you, Russell. Can you tell us a little bit about Woven Metal Products?
Sure, I've got a couple of slides to share. Hopefully y'all can see those. We are in Alvin, Texas, which is just south of Houston. We're a third generation family business. We've been in business for approximately 58 years, going on 59 next year. We've got 125,000 square foot of shop space. We are a job shop, mainly for the energy industry, specializing in ASME type work, but we are not a coach shop. We build child reactor internals. And then we've also been leaned on, especially over the years, as a specialty perforator and specialty custom fabricator. We just because of our location in Houston, obviously energy industry is a large driver, but we are in decorative work. We're in pulp and paper. We're in the renewable space. So we get to see and touch a lot of different mentalities from an OEM perspective to an end user perspective, construction, and that really has an impact on how we look at things, is because each customer looks at things differently, and because of our experience in such a vast array of technologies as well as customers, we will sometimes pull different concepts from different industries and say, yeah, but what if we apply this over here? And that really helps our customers develop new ideas and new ways to think about things. We've been leaned on by our customers for one of the reasons of our expertise, but also we have everything under roof. So when it comes to manufacturing side, we've got perforating, we've got laser, water jet, large plasma, as well as all the welding, forming, robotics, drilling. And because of that, we're able to control all the different variables. So it makes design, R&D, all of that more flexible, because we just go and say, okay, let's try this again. And our partners have really come to us, and I'll talk about this later, but our partners have come to us for that one-stop solution. And then how do we solve problems? And we've actually had the luxury of co-patenting and with international firms, and kind of that solutions provider is what we look at being.
Fantastic. Wow, you can really cover a breadth of fabrication processes. That's amazing. And I'm excited to hear a little bit more about those patented projects that you worked on. We'll go ahead and move to you, Ed Frymouth, and if you would tell us a little bit about Versatility Tool and Manufacturing.
Sure. I've got a couple of slides to share as well.
There you go.
Okay. Has that come up okay?
Yes.
Okay, great. So Versatility Toolworks, also a family-owned business. We've been in operation since 1972, second generation as well. My father started the business, and now my brother and I have carried on that tradition. And we are located in Alsip, Illinois. We've got 40,000 square feet of manufacturing space, and really the business started as a tool and die building operation, and sort of transitioned to stampings as the customers we were building the dies for asked us to run the dies as well and make parts. And then from there, we sort of transitioned more into a sheet metal fabrication company. So we have this great background in tooling, in die building, and we kind of use that as part of our package that we're able to offer customers today. But basically, we're heavily involved in engineering and co-engineering with our customers and designing their sheet metal parts. Like you said, Kate, that rang really true. We partner with electronics companies, with electrical engineering companies, with computer companies, and they're great at what they do, and their final products are awesome, but they're not always so they're not sheet metal experts, and that's where we come in, and we help them with that. So partnership is a really big part of what we do, and getting close to the customers. And you'll see later we actually have a whole process to do that as well. But basically, we're heavily involved with engineering. We're a precision sheet metal fabricator. We still do some stamping as well, high-speed stamping, as well as sort of more traditional long-run stamping. We fall back on that tooling and machining. We don't build tools anymore for outside companies. We do it all for our own internal use. But all the tooling and fixturing that we use in our operation is typically built in-house. Over the last 10 years or so, we've gotten involved in mechanical and electromechanical assembly. So we take our sheet metal parts that we build, and we put them together with circuit boards and other electronic components that our customers provide, and to make the final product. So we really do turnkey manufacturing in that regard, where we're making all the chassis, the housings, the enclosures, combining them with the other parts that the customer provides and that they've designed, and put them into a working product. And then something we've been really successful with is fulfillment collaboration as well, where we look at releasing product to customers as they need it. Sometimes shipping even every few days, rather than sending out truckloads of products. So that's kind of in a nutshell what we do.
It's a big nutshell. It's a big nutshell, but very interesting.
Yeah.
I know we talked a little earlier about your very kind of structured process for stepping through things with your clients, and we will get to that later.
Yeah, great. Yeah. And just a quick example of what we do, we have a couple slides here on just the products that we make, but a lot of enclosures. We work closely with architectural lighting companies. Still do quite a bit of precision machining, sort of tooling related, low volume, high tolerance machining, and high speed stamping, along with metal fabrication.
Okay, thanks so much, Ed. And then moving on to you, Kevin, if you would tell us.
Just one more thing. I just want to give us one more thing, is that we also have our own product line, which we sell and market under Versatility Professional Tool Storage. And this is just a little example of the things we do, but basically tool cabinets, changeover carts, and workstations for pretty much for industrial applications. So thank you.
Sure. I've seen those at FabTech. They're really cool. So Kevin, moving on to you, tell us a little bit about Rocker Toolcraft. Kevin, you're muted. Kevin, can you unmute?
Yes, there we go. Sorry about that. Had too many screens going on at once here. Let me get my slides pulled up. There we go. Can you see my screen okay?
Yes.
Okay. So we're up from Rockford Toolcraft. We've been around since 1976. Our focus is on metal stamping. We have presses up to 4,400 tons. Just some slides here. We have 2 large facilities nearing 500,000 square feet plant space, near 400 employees. And then just we design, build, transfer progressive dies. Our main focus is on heavy gauge metal stampings, but we also do work with fabrication. As far as press brakes and lasers go, we have 2 5-axis lasers, great quality control systems. Our main industries are heavy trucking, agricultural, automotive, commercial hardware, and then heavy electrical and industrial components. You can contact us if you have any further questions about any of that kind of stuff. I'll keep it short and sweet.
I was just thinking the same. Thank you for that.
No problem.
Right. So we'll go ahead and launch into our first question, the really main one. Which design for manufacturer strategies and approaches have you found to be successful? And again, we'll start with you, Jeff, and proceed through.
Well, I'm basically showing customers or potential customers how we can help improve their quality and lower their cost through design. We'll often get something in that is for quotation, and we will offer them suggestions on a second quotation that'll show a significant savings. We'll also point out quality enhancements that we're adding to the design. So that's mainly how we look at it. We look at it as an early supplier involvement with that.
Okay. And Russell, can you tell us a little bit about what strategies you have found to be successful?
Yeah, I'd love to share a quick story. And that
Love
is
stories.
so that is around we love to go talk to clients and just ask what problems they're having. And so it starts with talking about the issues. And then we start, and we really say at Woven Metal, we're a solutions provider, and we try to live that. And by living that, we go say, what are your problems? Tell us how we can help you. And the biggest thing that salespeople or our industry doesn't do is they don't listen. And they come in saying, this is what our solution is. And instead of give us your problem and then let us help you develop a solution. And so this is a picture. This is at the bottom of a reactor, and this is a standard outlet. And what happens is gas flows through this, and it's got catalyst around it, and they clog up. They have massive problems for what's called pressure drop, which creates it takes a lot of pressure, a lot of compression to get through them. And so we started listening to customers, and with that, we then went and we designed. And welding in our industry is a big deal, especially on ASME coated vessels. And so we designed a complete new solution that we then took to the client and said, hey, what if we did this? And we took that standard design and completely, redesigned it with their input. And so they were saying, hey, we need better distribution. Okay. We need it to look like this. We need less pressure drop. And we took their list of goals and we took it back to our office and to our designers and said, let's come up with a better way. And then we took version 1 back to them in concept and said, what about this? And of course, that's not where we ended up. But to make a very long story short, we took and looked from not only a process standpoint, we had to apply our mechanical knowledge and our fabrication knowledge to get to an end result. And so just because we could draw it or just because we could design it didn't mean we could build it. And so we looked at that. How do we not only design it from a process standpoint, but how do we design it from a mechanical standpoint? And then how do we install it? And so, because these are installed in refineries and chemical plants all over the world. And so we couldn't just look at our one little piece. We had to look at everybody's piece. And so as we take all of those inputs, we then came up with this concept that drastically changed not only their operations, but also made it better for the installer, which also then made fabrication easier. And so it was more about looking at that whole picture and involving all of the parties. And so many times we end up in silos of this is what we do. And then all of a sudden, when we start asking all the different parties, well, what would you like? And so, like in this case, we put 40% more catalyst in this unit. Well, that's massive reward for the end user. It's big dollars. And so with this, we then said, look, this is an industry changing thing. Everybody agreed. We went to we were working with one of the major technology providers, and we co-patented this. So as our small fabrication facility, and as we've grown over the years, as we've gotten bigger and bigger, we found that we are becoming that, hey, let's work together with these guys. Instead of just bringing them a solution, let's ask them a solution. And if we look at from a process standpoint, we can say this is a better solution, not only process-wise, but also fabrication-wise. And here we're doing CFD modeling, FEA modeling, not only looking at the mechanical integrity, but also the integrity of the actual process. So it's really about involving everybody and involving everybody really early, and then understanding everybody's goals.
Fantastic. It sounds like we're hearing some recurring themes of, working with the customer, and I love, listening to the customer and asking them first about their problems and trying to step them through solutions. That was really great, Russell. Thank you. And let's go on to you then. What strategies and approaches have you found to be successful?
We've really found doing what we call integration, process integration, on customers' parts to be, one of the most successful things. And what I mean by that is, combining whatever we can into the primary blanking process and leaving those things further downstream, being able to eliminate them. Examples might include, eliminating hardware insertion or PEM nuts, let's say, and extruding holes in the blanking process and tapping them right in the blanking process. So we've got some unique equipment that allows us to do that. And we've got punch laser combination machines. And those machines allow us to integrate, blanking, forming, and even tapping into the primary processes. So what happens is, we end up, instead of having a workflow that says, we're going to blank, then we're going to go and we're going to insert hardware, and then maybe we're going to go into the press brake and make some little flange forms, and then we have to do the main forming. We can do a lot of that. We can do 3 out of those 4 things right in our blanking process. And that's an incredible cost savings down the line. I've got an example that I can show later that sort of, leverages what we can do as far as that goes. And now in some cases, eliminating some of those features, that doesn't work with the customer's design, right? There's limitations. So it's, again, very important, what are the customer's design intents? What are the customer's needs for that part? And then once you kind of work through that, you can start to figure out where can we do this process integration, and where can we be successful at doing that. And, it's important to get them on board. We always try to make customers, particularly new customers or new employees that we're working with at a customer site, there's a new engineer, make them very aware of our capabilities and what we can do, so that they can also start to kind of have those kind of thoughts. And it's a lot of times easier to sell that to them, if they have some of that knowledge. But that's really been one of the most, I would say, key things is the process integration.
Oh, very cool. Thank you so much.
Mm-hmm.
That's really good, Ed. Kevin, can you tell us a little bit about the strategies and approaches that you have found to be successful for design for manufacture?
Yeah, so as others have kind of said, having early collaboration is critical to the whole process. We as the supplier and the tool makers, the fabricators, we know what our tools are capable of doing. We know what's possible, whereas the customers don't always have that background. A lot of the engineers are straight out of engineering school, and they can design a beautiful part that works as well, great in their assembly, but they don't know how things are actually manufactured in real life yet. And so when we can kind of give our 2 cents of, hey, this radius is too sharp, or that hole's too close to the edge, or this formed leg is too short, we can give them insights towards their parts, and then they can redesign the parts based around the process that we've quoted. And then that saves a lot of headaches down the line, because, we're not chasing our tail trying to fix a problem that it doesn't need to exist in the first place, So if we can collaborate on the design in the early stages and kind of be that trusted advisor to them, we don't run into those same issues. So I guess in summary, just collaborate early, collaborate often, and really just continue to have a good working relationship with customers and suppliers.
Very cool. Thank you, Camden. So it sounds like we have some very strong recurring themes. Anybody want to comment on what anyone else said or questions? Brad, it looks like we might have some questions that came in from the audience.
I have a question for you guys while you're preparing for the next question here, Kate. Do you guys find that design for manufacturing is becoming more and more important over time? Was it always important, or is this really becoming more of a deciding factor sometimes when customers are deciding who they want to work with?
I can speak to that from our industry's perspective. It is absolutely becoming more and more important, and the reason is the knowledge base at a lot of our customers is different over different experiences. We have you used to have, and this is speaking very historically, you used to have a lot of fabrication knowledge within our customers' facilities. That's not near as much the case anymore with some of the streamlining that has been done. So they're coming to us not only asking what you can do, but also how can you do it. So we find that we're really successful when we actually go in and teach or bring them in to teach. Especially somebody was speaking about the younger mechanical engineers, bringing them in and showing, just because you can draw it doesn't mean I can build it. And so, or if I can't afford to build it, or how do I build it cheaper? So I do feel like that is a value add that is quite frankly more and more important as the industry moves on.
Yeah, good. Thanks for that feedback. Anybody else want to comment on that?
Yeah, I agree with that. I mean, product life cycles are being shortened all the time. You just get a brand new cell phone and it's already out of date. More and more products are being produced and upgraded constantly. So they are always making updates. Engineers don't want to go back and change something that they did 2 years ago or a year ago or even 6 months ago. So getting in early in the stages is the best time to utilize and get that relationship built with your customers. You could also, map the costing, cost reduction mapping, and do any type of material issues or anything like that. As Kevin brought up, you often see it where they put a hole too close to a form or something too tight of a radius where you can crack materials and so on.
Very cool. Thank you so much.
Let me pose this follow-up question, if you don't mind, guys, Kate, that we got from the audience. Generative AI. So I was going to ask you if there's tools that you're using for design for manufacture that are helping with that, streamline that process, make it more impactful. And everybody's talking about AI. Is generative AI a tool that you guys have used or started to look at using when it comes to DFM? ChatGPT or any of these other AI tools?
Yeah, I mean, I've personally plugged in certain material types to look for more information. With ChatGPT especially, it gives you a ton of links and information and kind of summarizes it all in an easy to digest manner. Instead of just me spending hours and hours Googling and going down dead ends of bad information. And I think it does help you and stuff that you're not familiar with, at least open the door to other conversation and having more information. I guess it's just readily accessible.
Cool, interesting. Anybody else?
I can add a little bit to that, but that's a great question. We've actually been looking at a new quoting system that analyzes the parts and looks for based on rules that you set up, looks for those kind of problems. Holes too close to an edge, wrong, radii that may not agree with your tooling set. And you can kind of program that, and then they'll actually analyze the part. So the benefits obviously are you're seeing this in the quoting process. It's not going to be missed, if everything's set up right. And then you can take that feedback back to the customer. So there's definitely, it's the first time it just in the last several months that I've seen something like that, but we're definitely investigating that and learning more about it.
That's cool. Do you want to share who the vendor is for that technology?
It's a company called Paperless Parts.
Oh, sure. Yeah, we know Paperless Parts. Okay. Very good.
I would say on that, we are seeing it. We're seeing it. We're using it for assisting with some scheduling things. We're using it for assisting with shop layout stuff, optimization opportunities, the research point, estimating. We're seeing it, but we're still so early. And the thing that I think that's really important to remember is, and we're also seeing that it's it's a large language model. So the LLM is only as accurate as the information in it. So it's not accurate. And so as we build, and I absolutely think it's going to be something that has a drastic impact in all industry. But it for me is still very, very early, and you've got to have the expertise to be able to understand and interpret the difference between it's giving you good data and bad data. And I think just a lot of data. We're using it to comb through data we know is good, but just combing through general data, we've seen some things that could take you down some pretty bad paths. Let's say.
Sure. Okay.
Yeah, you basically have to make sure that you're giving it a good source for your data. We use it for quality issues, things that way, looking for trends, looking for materials, especially as we're getting things that are being made overseas, brought into the U.S., getting the like type materials, because we don't have those certain types of materials available in the U.S. What is like that? But then you still have to do the research and qualification. And I agree with Russ on that you really need to be careful with it.
Okay, good. Thanks, guys. Kate, go ahead.
Okay. So I'm going to go ahead and jump to our third question. Let's give some specific examples. Can you cite some specific examples of design for manufacture? Maybe some visuals showing kind of the before and after on a CAD design or whatever. Lead us through the steps that you have taken in a specific example. And I'm going to start again with you, Jeff.
And a lot of our products are not our products, so I can't show those type of examples. But where we start off with our customers is we look for proper dimensioning. We inform them of different tooling options. One of the things you'll hear, and we do some seminars and lunch and learns and things that way, is I need hardware, and I can show you how to eliminate it. Material reduction, alternative fastening methods, material types, eliminating secondary operations, and one that I think everybody that's on here will agree. Customers always put it on their parts must be burr-free. That's going to cost more money to do that. Is there certain sections or areas where you have wires going through or something like that needs to be deburred properly? So those are some of the areas that we look at in our process. And we work with our customers engineering to dive into those areas to see what we're able to do.
Very cool. Russell?
Yeah, so I kind of started on that question, definitely showed examples of where we have done that to start off with. But what I would say is let's talk about the evolution of that product. And so that product started out with a very simple application that solved a problem. Where it has evolved to is exactly what we're talking about of going through and listening to other customers. And we've taken it into different industries. We've taken that same solution, applied it with different materials, different construction techniques. They had different goals, but at the end of the day, we were able, and we've actually filed 2 patents past the initial patent, just because we're continuously improving and evolving that equipment. And so it doesn't start and or stop with that one solution. As you keep going on and on, and as we see so many times in our industry where okay, we came up with the answer. Now let's move on. And it's really about continuous improvement. And if you do that on every one of your products, your customers will keep coming back because they still see that innovation and they see that growth.
Very good. It sounds as though you really do have progressive products in the sense that the concept progresses and continues to progress. And I love that you co-patented some products. And do you have any visual examples of like a before and after type
Well,
of thing?
that's absolutely what I showed. I mean,
Okay.
you know,
Maybe we can put that up again.
I absolutely can.
Okay.
So the before looks like this. So this is a before, and we still make this product a lot. So this is the before. It's very small. It's very simple. It does the job.
It's not appearing on the screen.
Well, it says it is. Let me try again.
Taking a minute. There you go.
Okay. So this is the before. You've got a very small manufactured part. It is about, I would go an 80-plus-year-old technology that has been used across industry, maybe even longer than that. There's been very small variations, but the actual tech behind it is very, very old. So this is the new. So if you look at this picture, basically it's the difference between just that little circle in the middle and the whole circle. And so not only is there a lot more fabrication of this, but there's also longevity is a lot longer. I mean, when we start going through the pluses that we didn't even realize. So for instance, we put it in an application, never appreciating what it would do. And in this application that they wanted, they're continuously cycling valves. Well, because of what they were able to do by putting this in, they cycled their valve count by a reduction of 75%. Their valve life went up by a factor of 75%. So the downstream costs. So for instance, in this application, and this is in large refining, the entire project paid for itself in less than 90 days. Including construction, including downtime, including everything. So it's that shift changing and industry changing kind of manufacturing that really is what that's why we were able to patent it, and that's why so many different parts of the industry have said this is the right solution.
That's very cool. It's really good. I'm going to leapfrog over to you, Kevin. I know that you had some specific examples you're going to show. And then you're muted again, Kev.
Okay, there we go. All right, so this yellow part here was the part that we originally quoted. It's a good sized drawn part. I think it's about 16 inches across this way and about 9 inches across this way, the flat pattern you see. It's a good candidate for a drawn part. We don't have any issues with it. It auto foamed great during the quoting process, but by the time we got the actual PO, the part looked like this. And so it changed pretty drastically on this back edge or on the front edge, and there are some significant changes to it. And when I ran autoform on it again, this whole back half of the part right here was blowing open, so completely breaking. So we then had to go back to our customer with a part that I remodeled up, which you see right here, with some little bit more generous radii going on. And then especially back in this area, I was really able to duff off this radius here to go from this to this. And this part autoformed successfully. It still worked within their assembly and what they needed it to do, and we didn't have any issues. And I guess that kind of brings us back to the first point, where if we can collaborate early and often, we are able to have that communication with our customer where the customer says, this is the part and it works. And then we were able to say, no, all right, your new part doesn't work. This will work. And they just kind of take our word for it and run with it. And they plug it into their design and make sure that it matches what they needed to do, fit, form, and functionalize. And, everybody ends up happy because the part works. It works for us. It works for them. And it just works.
That's great. That's a really good example. Ed, can you go ahead? I think you had a couple of slides too.
Yeah, I do. Hold on a second here. Okay, how are we looking there? Did the slide come up?
Yes, it looks good.
Okay. So this will get me into, I'm just going to very briefly look at this process, but we did, so getting back to collaboration and how you manage these type of interactions with customers, we've been doing this for many years and been successful with it, but we never had a process, or we never were aware that we had a process. And one of the things that we sort of, as we were growing and we had different engineers coming in or different salespeople coming in, we found that the process that the customers experienced wasn't necessarily consistent with what we used to have, right? So we wanted to present a consistent approach with the customer and make sure that we're getting the right information from the customers and make sure that we're getting the right feedback back from them after we are suggesting design changes. So we came up with this, we didn't come up with it, we were doing it all along, but we basically said, well, what is our process? So we went to our customers and we said, can you, help us? What do we do that you like? And then we said that, to our veteran employees, well, what have we been doing? How do we like that? What do our sales guys do? And we kind of looked at all that and we formalized what we thought we had. And basically, there's nothing, that's the great thing here. There's, this is not a groundbreaking process. It's just that it's something that we evolved into over time, and it works really well. But we're not inventing anything new, but it's important to have that discovery process, right? I think several of us have spoken about that early on, and make sure that that's and that's a super important part of this Q-step process. Engineering engagement, working directly with the other company's engineers, working with the guys that are designing the parts, giving them access to our engineers and our tooling experts, that have been working in the tool and die and industry for years. That's where important collaboration takes place. That's where you can save a lot of money for your customers, because they're looking at, hey, if you make this one design change, we don't need to build an expensive tool. We can do this in another way. And those are all real important. Going into fabrication, we sort of hang our hats on some of the processes that we're able to offer. Again, that process integration, that there's, you can laser cut, but you can form, you can extrude, you can tap, you can do knockouts, you can do all of these things in one process. That's all part of this offering that we'll be able to give to the customers. And then we at the back end, we pull it into fulfillment, because that's an important part of it as well, right? How are we managing the deliveries? How are the customers getting, it doesn't, sometimes low volume jobs, we may look at a few hundred pieces, a few hundred assemblies, but it's not really practical to make that many, necessarily. So do we tell the customer we need to take 1,000? Well, no, maybe not. Maybe we can come up with an agreement where, we're running a little larger lot, but we're able to hold on to some of those for the customer. We come up to an agreement where you have to use them in a certain amount of time or something like that. So that kind of encompasses this whole process. It's really been working well. We have some other things, like we've got some flow charting that we did, that we give a new engineer. Hey, here's the flow chart. Here's how you analyze a new job. you go through it, because again, we have stamping, we have laser cutting, we have punching, we have different processes. Well, what's the most appropriate process? What makes the most sense from a business perspective that this part can take? So, when we quote it, we have to make those decisions early on so that we can give the customer, basically the best quote that we possibly can. And so that all goes into this process as well. So it's just basically a formalization of, the things that we've been doing for 50 years, right? And we've kind of pulled that all together and we put it down on paper, and we actually have it. We have a service mark for this with the U.S. Patent Office, just because everybody was telling us, well, this is really unique, and that's the one thing that we heard from customers is, yeah, not a lot of other people do this kind of thing with us. And that's one of the things that, that really separated us, I think, from some of the other people out there is, we're really getting into the weeds. We're really looking at, now there's some customers, they have a lot of sheet metal experts that are designing their parts, and we know who those people are. And when they send us a part, we can put it through our process and no problem, right? There are those other people where there's all kinds of issues, and this is where we get to those issues. So, but I'll just give you a quick other example of how we applied this process. But this is very simple also, right? This is just the customer came to us and said, hey, this is a low volume job. We need to be able to control the cost better, though. The prices we're paying now are too high. We're having a hard time being competitive with that. And the parts are taking too long. So who hasn't heard that before, right? It's too expensive and it takes too long. Well, that's basically what this customer was telling us on this particular part. And the part we're talking about, I'm going to show another slide of it here in a minute, is this silver part sitting behind this faceplate. So this is this customer's builds, designs electronic signboards and mass notification devices. They go into a lot of schools, universities, airports. You see them a lot. On college campuses, things like that. But this particular one is this box behind here sits inside the wall. This plate here holds the display and the speaker. So basically, they're asking us to do something with this box. Well, when we got it, it was made out of a fairly, for the application, it was made out of a fairly, I think it was 18 gauge material. It was made out of carbon steel and it was painted. So what we suggested here, we did really, three things as we went through this process. And again, you're going to hear the same words again. Material selection. I know one of the other guys talked about that. I talked about process integration, right? And innovative engineering. We've all talked about that. So these three things went into this as we applied our Q-step process. But one was a material change where we went from 18 gauge carbon steel to 22 gauge galvanized steel. We didn't need to have that really heavy steel there. And it didn't need to be painted. It's going inside of a wall, a galvanized part, it would be good. So that resulted in a 30% material reduction usage and a powder coating process eliminated. So again, we're going after process elimination as well, right? We've eliminated an entire process there. We've used less material. The second thing was, again, process integration. This initial design had 4 PEM nuts in it. Well, we went with using our laser punch combination capabilities, and we're extruding holes in the part. And we have 4 tapping heads on our machine. We can tap that hole after we extrude it. So again, PEM insertion process eliminated, and we've reduced material usage again. We don't need PEM nuts. We're forming them out of the metal itself. And again, next process integration. This box, this simple 4-sided box, was also welded. Well, when we looked at it, we really said, well, okay, but does it really need to be welded? And again, welding is another process. It's more handling. It adds to lead time. And we really looked at maybe we can eliminate the process. And we designed a snap together shear form feature so that when this box is bent in the press brake, the corners actually snap together, and they're snapped together, and it's strong enough that the customer approved this as a solution. And we took these, so we looked at these things and we brought that back to the customer. We did a virtual prototype We showed him what it would look like. We showed the how to snap together feature worked, and everything was approved. And then so what kind of happened was we went from what he brought there to this. So this is the snap together feature here. I've got a couple different views of it. It's kind of hard, and I've got some pictures in the next slide, but you can see this little red tab here. But basically, we're forming that out of the box. And then right on top here, and in this view, that's another form that's formed back down into the interior of that little shear form. And what happens there is there's a hole that's punched in this flange. This is normally where the welds would go, right here and here. But now the flange slides underneath that form feature and snaps right in there. So, and you can kind of see the design here from the side. It's kind of got kind of like a wave form to it. But when you look at what that looks like on a flat blank, and here's kind of going to be the three big changes that we made, right? Here's the form feature, the shear form feature to snap together. Here's the hole that's punched in the flange. So when this is folded together, this little shear form on top here is going to snap in there. And then over here, you can just barely see, I think, the extrusion, and that extrusion is tapped for an 832 screw. So this is kind of what the flat blank detail looks like. And we repeat this on each corner. So it goes around the 4 different corners. And then basically, this is the finished part here. Again, simple part, but we've made these changes, and you can see here in the corners, here's that snap together feature. Up here on the top, this is where that front plate mounts. Those are the 4 extruded and tapped holes. And this is a laser cut part that is also being having these formed features added to it as we go through the blanking process. So that was that we made prototypes, we tested them, the customer tested them, everything looked good, and they were happy. But it's all fine, to be able to do these things, but what are the results? What did it really mean? Well, by reducing the material thickness, and we were able to reduce usage by about 30%. By integrating the welding together into the blanking process, right? We did that as well. So we eliminated a process. We integrated the hardware insertion process. Again, we eliminated a process with tapped extrusions. But the business results, unit cost of this particular part was lowered by 34%. Lead time was compressed from 22 days to 10 days. So they're right there at the customer's goals. And we impacted those pain points for him. And basically, at the end of the day, we had a very happy customer. So that was a good success story for us by utilizing the Q-step process, utilizing the capabilities of our manufacturing and engineering and tooling design, because our engineers came up with that snap together, and we did a couple different iterations before we got it right. But at the end of the day, this was a big win for the customer.
It is an excellent example. I loved how you were able to show, changes in material, changes in process, not painting, going to galvanize instead of painting, and the ultimate, best scenario for your customer is not only a good process, but reduced cost. I know, Jeff, you were talking about that, about how you work with your customers and are frequently able to reduce costs. Do you do any of you? I'm going to open this up to all of you, because as we're kind of getting close to wrapping up here, this whole session went so fast. But I just like to, just ask all of you kind of open-ended here then. Do you find yourself surprising your customers by reducing the costs of their products or fabrications? Are you finding it with material changes, with some process changes? Are there some fabrication processes they weren't aware of that are better suited for their products? And then we'll have to kind of wrap it up after that. So whoever wants to go first, go ahead.
And I kind of agree with what Ed had there. We've often looked at different ways of joining parts together, hardware elimination, like fastening options. We've used the same tab for like 20 years. toggle locking, as well as swedging and other types of tabs and slots and things that way. We also look at how we can poke yoke the design as we're going through it, so that when things get formed up and other parts are coming into play, it reduces their amount of assembly time. So it's important features to know and discuss with the customer up front to know exactly where they're going, where we're going to see the benefits. I've seen it where it's a 10% cost reduction, and I've seen it as high as going up to 50% cost reduction through design. Sometimes it's finishes, sometimes it's materials. It's a variety of different ideas and things like that way.
You know, for me, we look at it a little differently. I mean, obviously, you try to do everything you can to reduce cost and make it as economical as possible. But at the end of the day, for us, it's really about value. And so, and that's, you know, cost is a function of value, but there's so many other factors. And so, understanding what their goals are and understanding, are we adding value or are we subtracting value, and what is the value proposition around what they're needing to do. And so understanding those goals, what drives them, what, you know, if we have, you know, many customers are driven by cost. Many customers actually, at the end of the day, when you really look at it, they want a fair price. But more important to them is they need it expedited. They need it they need it now, or they need to make sure that they don't have any quality dropouts. They need, you know, so understanding the value proposition, as well as how to give them that value proposition so that they feel like they're getting value and that they are getting value. And if part of that is reducing cost, then that's absolutely a piece of it that you try to go after. But I think as you educate clients, and I think it's a whole educational piece of driving, not just how do we drive the cost out, but also how do we drive the value up.
Good call. Very good point. Yeah, there are more strategies than reducing cost in value and expediting the process. You know, another one too, just making sure things work better. Anyone else, Kevin?
Yeah, I guess the one thing I can kind of key in. So we've had a few products that were originally they were fabricated parts. So, you know, laser and press brake and blah, blah, blah. And we were able to take those parts and turn them into stampings. And one of them we actually were able to reshore from China back here to the United States due to that process. So they were, you know, it was literally like a lasered part that they press broke and welded together, and we were able to do it complete off the die with the drawn part. So I mean, that was a huge cost savings, a huge time savings. It was a great boost in quality for them. It was just a way more consistent process, and that customer has been a customer since.
Very cool. That's a great story. And then I think you probably have something to say.
Well, no, I think that Russell, I think, brought the point value. I mean, I think that's really key, right? And I think value added as you make customer relationships. We don't want to be commoditized, right? I mean, so we want to be able to we want our customers to say, you know, these guys really do something else. They do a little bit different. They do it a little bit differently. And that's adding value, and adding value by, you know, one day it might be you're saving some cost. One day it might be improving quality. One day it might be, you know, improving design, part functionality, whatever it may be. There's all these different facets. But at the end of the day, the bottom line, I couldn't agree more, is adding value. And you really have to make your customers sort of understand that. And that's why we try to educate them on, you know, kind of what we bring to the table. And I think that's a very important piece.
Well, thank you, everyone. This has been just really very illuminating, and I wish we could continue more and talk the entire day, but, you know, some other people want to get in here too. So I guess we have other topics to talk about. But thank you. I'm just thrilled that you were with us. I so much appreciate all your contributions. And we'll wrap this up right now and move on to the next topics. Go ahead, Brant.
Yeah, thank you so much. Like Kate said, to the panelists, you guys did a great job. Appreciate your time and sharing sharing your applications with us. The slides and the photos and the stories were really informational. I hope the audience got a lot out of it. Thank you, Kate, for doing a great job moderating. So we're going to take a 5-minute break. I know we're right at 11:45 here Eastern time. We'll take a 5-minute break. We'll come back for our panel discussion on automation strategy. So we'll head out into the shop. We've got some panelists. They're going to share their automation stories with us. So we'll be back with you in 5 minutes.
Thanks for having us. Appreciate the time.
Thank you very much.
Yeah, thank you very much.
Thank you.
Thank you.
All right, let's get going with our second panel discussion today. We're going to talk about automation strategy for the sheet metal job shop. We've got a few experts from the field who can tell us what they've been doing with automation projects, what the strategy is. For that conversation, I'm going to turn things over to Metal Forming Magazine Senior Editor Lou Kren. Lou, take it away.
All right, thanks, Brad. I appreciate it. And thank you, Kate Bachman, for the earlier panel session and for those panelists. And welcome back to the Metal Fabrication Strategy Summit, produced by Metal Forming Magazine and PMA. It's time for panel discussion number 2, automation strategy for the sheet metal job shop. Just a couple real quick reminders. The meeting's being recorded. They'll be posted to our website in the next few days. We'll let you know via email when it is available for viewing online and for sharing with others at your company. Also, participants are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your site during the program. However, being a panel session, we obviously want a lot of give and take, and we want your questions. So please be sure to use the Q&A button at the bottom of your screen to ask questions, and they will be addressed during and most likely at the end of this panel discussion. Okay, let's get started. Automating fabrication processes pay dividends in upping productivity, relieving employees from unsafe and monotonous work, and increasing opportunities for new work by opening up machine availability. But automation, if not done right, can be an expensive boondoggle. Here, the goal is to learn how to assess automation opportunities to get the most bang for your buck. And joining us for this 45-minute discussion are Jeff Deck, consultant and former president of Laystrom Manufacturing Company, John Axelberg, CEO of General Stamping and Metalworks, and Stu Swanson, fabrication engineering manager, Capco Metal Stamping. So thanks for joining us, panelists. And maybe if we can just go around the horn here real quick. I know, Jeff, you were on an earlier panel, so I'm going to ask you to repeat yourself just a bit. But so maybe if you could give a quick personal and company introduction, and then maybe just a minute there about some of your recent automation activities to kind of frame the conversation today.
Sure. Jeff Deck, former president of Laystrom Manufacturing. We're a sheet metal contract manufacturer in Chicago area, family-owned business, and 74 years in the business. I haven't been around that long. I'm a little bit younger than that, but I've been around quite a while in a lot of different areas. And one of the things that drew me to Laystrom was the automation that they had in-house. So latest automation that we've installed is a robotic welding cell, but we also have cobots in-house. We also have a automated lasers, 3 of them. So we're capable of burning quite a bit of material over the weekend with nobody even in the building.
Yep.
So,
okay. Thank you, Jeff. John? John, you're muted.
Thank you. So General Stamping and Metalworks is a 103-year-old stamping and fabricating company, headquartered in South Bend, Indiana. We also have a facility in Toma, Wisconsin. About 340 employees. 340,000 square feet under roof. We're 103 years old, but I've been here a little under half of that time. So, so I've seen a lot of changes in the automation environment. But some recent ads that we've made, a punch laser combination machine, which we were very careful to install, making sure that it was positioned to integrate with future automated storage and retrieval. And a transfer system to a 2,000-ton press, and then a tower storage material handling system for a couple of lasers in our Wisconsin plant. Just a 10th robotic welding cell, which was dedicated to stainless steel. Big project right now is machine data integration. So, we're getting all of our machines to report production directly, and not requiring the operators to do that. So that's the recent stuff.
Okay. Thank you, John. And Stu?
Yeah, hi, I'm Stu Swanson, fabrication engineering manager for Capco Metal Stamping. I'm on the fabrication side. We are a contract manufacturer north of Milwaukee, Wisconsin. We have about 5 plants throughout the Wisconsin area, just under 500 employees. We have 13 robotic weld cells, about 12 press brakes, 3 of which are automated, 2 with cobots. We have a stamping press with a cobot and 3D vision system. And recently, within 2025, we put in a Mitsubishi 20 kilowatt laser with a tower and an ASTIS 4 automated denesting, and then a Trumpf 7030 with automated denesting and a tower as well. Previously, I started at Capco 4 years ago as an automation engineer, and then I was the automation engineering manager, and now I'm over fabrication engineering. So great to be here. Thanks for having me.
Okay, thank you, Stu. And it wasn't too long ago. You might buy a laser cutting machine, press brake, punching machine, and we'd always ask, "Have you thought about automation?" And I think nowadays when you buy that, you have to include automation. The speeds are, they're so quick and so much going on. You have to keep that investment fed, and you have to keep material going on and going off it constantly. And with that in mind, maybe if we could start with you, John, about an overall automation strategy. How do you incorporate that strategy into short and long-term planning?
Yeah, well, we've involved from a pretty ad hoc, just situational approach to something a little more overarching. And really, our sort of guiding principle is the assumption that everything will one day be automated. So what is it about the systems that we use today that will have to change? Now, is it likely that everything actually will be automated? No. But the assumption is that if we approach it that way and try to develop our systems that way, they'll work better for people too. Things like one of the big things that we've had to address is all of our critical work instructions were text fields in our routing. And, how would a machine be able to read that? Well, they can't. So we're moving that stuff into data fields that are searchable. It can be queried and actually used in the context of automation. You know, and one of the uh, things that we've learned over the years is that, yeah, automation reduces point of operation labor content, but it requires a lot of engineering, project management, and maintenance resources that may not be present in the organization as it exists. So, you know, we've had quite a few automation implementations that were really slow to take off because, you know, we didn't think about what we would need to add to make them work effectively.
Did you find that, did you bring in maybe personnel first in that capability, or is it just something the current personnel you learned along the way, or how did you address that?
More the latter, you know, and we did it by people with full-time jobs already working harder. We are, and it's interesting that Stuart actually started as an automation engineer. You know, we've got our first dedicated automation engineer coming on staff in December, and it was something we probably needed for years. So I'm excited about that.
So, Stu, maybe you could kind of add to that conversation about how, you know, an overall automation strategy. How do you go about?
Yeah. So Capco did it a little bit different than John. When Capco decided, you know, they wanted to start automating and bringing in robotics, they hired myself and another automation engineering tech, to kind of kick that off. And the idea was we weren't tied down to the day-to-day operations of the company. That made a big difference. And, you know, Capco was willing to make that investment. Obviously, you know, you're not going to get your return right away. You got to kind of bring these people in, and then kind of kick off the automation project. So when you're looking at kind of a short-term and long-term strategy there, you're not going to see that ROI, you know, on those positions for probably at least a year, just because of how long automation projects can take. But I'll tell you, it was a big benefit for me to be able to invest all of my time into, you know, researching equipment and finding the best solution for our processes, instead of just throwing that at someone that, you know, already had a day job. I got a lot of comments, you know, when we were going to different shows and demonstrations that, you know, a lot of companies don't do it that way, and we were lucky to have that support. So I would suggest that if you can somehow fund an automation team before diving into automation, that would be a benefit for sure.
I second that.
And Jeff, do you third that, or can you talk a little bit about automation strategy overall?
I do third that, but our automation as John had said, it was more ad hoc. At first, when we first got into automation on our lasers, it was something that we saw that because of productivity increases and things that way, that we needed to get into. To use that lights out time to actually be cutting materials and stacking them and getting it ready and things that way. So we did it to the point where we took some people out of production and we took some people in engineering, sent them off to school. Okay, they actually attended. We bought an Amada product. We sent them to Amada for the training. They learned the systems inside and out and how to utilize them the best, made right by the OEM. So we were getting firsthand good information, brought that information back to the plant, installed our first 2 lasers and started running them. We had a robotic welder at the time. It was worn out and we ended up getting rid of it. We didn't have a lot of welding at the time, so we didn't replace it until just recently. Um, in between there, we did a cobot implementation, and we looked at the cobot as a way to basically get another operator and things like that. We brought people in, did training in-house on that one. The company that we actually purchased it from provided in-house training, so we brought them in. They helped us to get implementation. Employees were brought off the floor basically, and they knew about the automation of the cobot coming in ahead of time. And basically, we're looking at what's the most boring job out there. Okay. And does it have any volume to it? We happen to start off in a multi-head tapping unit where one woman that was running it said, I hate this job. I sit there for 3 weeks every time we run it. I'd rather be on a press. I'd rather be doing something else. And you know what? She was better off on the press. We were getting more out that way. So we implemented the cobot into that area. We also had it on a punch press. We put it on a press brake now. So the flexibility of the cobots has been a help to us. And now we're just adding more to it and adding on to it, things that way. Safety is a big feature as well. Safety is one of our core competencies. We've gotten up to 1,489 days without a lost time accident before we had one recently. So we want to build that back up again. And we've always been a very safety conscious company. So that was another thing. If you get a person that's so bored on their position or their job that they're doing at that time, there's more chances of an accident happening than not paying attention to what they're doing. So that's why we went that route. With the robotic welder, we saw volumes picking up. So productivity was the key to bringing that one in. We did take an engineer and we took two people from the shop, one on first shift and one on second that were welders, and we sent them off to school at the OEM again. And we got them out to Ohio and got them trained. They spent 2 weeks out there at different times, 1 week at a time, and came back and were able to smoothly implement the product into the company.
Okay. Thank you, Jeff. And you bring up an interesting point there about feedback from the shop floor and how it affects automation decisions. So maybe if I could take that up with Stu and John about what do you think about the importance of feedback from the people who are using the equipment every day and this and that, and how does that affect your automation decisions? And if you might have any examples of that, maybe if we could start with you, Stu.
Yeah, so I will say, if the floor is against automation, it's probably going to die. You need buy-in from the shop. I think that's what is so powerful about cobots, because you enable shop employees to, in our case, I mean, they create the programs on the floor with cobots, and they see the value in that. But as Jeff was saying, I think it's important to get the shop workers involved with the project. It's great if you can pull people from the floor that are interested in automation, that want to get involved. You kind of create that excitement about what automation can do, and it's not necessarily going to take their job. It's going to make their job easier, and it gives people an opportunity to take on those technical roles that they may otherwise not have ability to get involved with. So it's a very powerful thing to bring in. You have to be careful. You have to do it right and have the right kind of culture. From a safety standpoint, I would agree with Jeff. We generally look at, number one, how to pick a job to go after for automation is going to be safety. We'll jump into our system to look at, what recordables have we had and look for patterns and part types and things. We have what are called, safety critical parts that may have pinch points, at a press brake. And we're definitely going to look at those parts initially. Can we automate? Can we use a cobot for that? That's kind of where we start, and then get into ergonomics and things, and making the shop a better place to work for the people that are out there that live in it, right?
Really? Okay. And John, if you could talk about, shop floor feedback and this question kind of turned into, a discussion about cobots. So if you want to address.
Yeah, well, I'll swing back to robots. We somehow ended up MIG welding a lot of galvanized steel for a couple of customers. And it started out small, and we were doing it in our manual welding booths with source capture units, which the operators couldn't remember to move as consistently as they needed to. And it became obvious pretty quickly that, hey, we just need to get all of our galvanized welding onto robots. It's a big quality of life issue. And, once we made that commitment, I don't think we had any welders who were unhappy to lose those jobs to a robot. And same thing with bending. We have one large cell in Wisconsin that'll handle a 220-pound workpiece. So, we try to migrate everything that would require 2 operators to that machine just for safety reasons. And of course, it ends up being more productive at the end of the day as well.
And, when you're installing automation, your laser cutting, your press brake automation, whatever the case may be, there's a lot that, happens upstream and downstream that automation affects. Maybe if we could start with you, Stu, maybe assessing upstream and downstream, processes and how automation fits in that, and the decision making on that. Does that, is that part of the planning process, or do you have any horror stories about that?
Well, you hope it's part of the planning process, but I'll give you an example of where we've missed a little bit. So we put these automated laser cells in, and they denest the parts automatically. Now, like in the case of the Astes 4, it doesn't necessarily remove all the slugs. So you do what you can with laser programming and get the slugs to fall out in the laser itself, but inevitably some of the slugs get stuck in there because of the slat table. And we're a big stamping house, so we're cutting a lot of blanks that are going to a stamping press, and a stamping press cannot have random slugs in the die. You'll crash the die. So we've had a lot of challenge. How do we guarantee that we're not gonna send slugs to the stamping department? And the issue there is we've put labor kind of at that. Someone's got to check for slugs coming into the stamping press, because we don't want to slow the stamping press or the stamping press operator down. So I think one of the pitfalls of automation sometimes is, you don't want to just shift the labor by adding automation. You took the labor away from the denesting operation, but if you're adding it back in a downstream operation, it's not as effective.
Jeff, can you add to that?
And we cut almost everything on lights out at night and things that way. And we've had slug issues and as well, Stu. We've come across different ways that we're handling them, but we have issues that come up, and we go through and we bring the right people together and we resolve those. So.
And John?
Yeah, I think, one of the big challenges we've run into is with automated welding. We've got some parts that are we're welding hundreds of thousands of parts a year, and um, one example, we get 42 parts on a pallet, and that is about 50 minutes of production time. So what we really underestimated was the amount of material handling support that would be required to, keep the cells supplied and keep finished goods cleared away. And it just showed up in the production data. It's like, man, we know what the cycle time is. Why aren't we making more parts? Well, because the robots are sitting there waiting for a forklift driver. So we're actually working with the engineering group at our local university to implement autonomous mobile robots in a couple of critical loops, and think that can just help address that. But yeah, that's just something that we didn't pay enough attention to. It's a bit of a surprise.
And we have a question that came in via the Q&A button, and we hope you continue to use that out in the audience. This has to do with, automation. It's typically thought of, you want to automate monotony, or the boring same stuff all the time. That's not necessarily true anymore. There's a lot of variability and flexibility in automation, but how do you address the potential, maybe long setup times with, if you have a high product mix and low volumes, setup of automation? Would someone like to address that? Maybe Stu, can I put you on the spot?
Sure. I think, one way we're a contract manufacturer, so we deal with, high SKU count and low volumes all the time. You have this technician out on the shop floor that's running really multiple automated cells, right? So if you think of press brakes, we'll have one operator technician running 3 press brakes, usually automated press brakes. So while their 2 press brakes are running parts and they're feeding those and keeping them full of material, they're doing a setup on that 3rd press brake. You're always going to get hit with setup, and we do a lot of things to try to optimize that. We use pin tables on our cobots, and we make templates. You put on the pin table, and it shows you exactly where to put the pins. We take lots of pictures. Pictures are free. We put them on the controller, so they're easy to identify. We store all of the tooling, right at the machines. Just keep everything local there. They have their own computer system, so they can log in. We have tablets at the machines. We have deployed some AMRs that John brought up, and we actually use tablets to kind of call AMRs from across the plant, with material. So we try to keep that operator at the equipment as much as possible, keep them maintaining the other equipment that's already running, and kind of rotate that process.
John or Jeff, would you like to comment on that?
Sure. Basically, what he was saying there, what Stu was bringing up, we look at that ahead of time, and we look at SMED techniques, basically, using the single minute exchange of dies. It's, even though we're in a contract manufacturer, a short run product and fabrication and things that way, where it's high mix, low volume, setting things up where you have pins or mounting in the floor, things that way, so you can just drop the pins right into it. You're always loading the same area. You set up cassettes of stock to go ahead, so you can build it up as you're taking it out of the nest of the turret or laser. Those are all things that we look at ahead of time, so that applying those SMED techniques can help with those type of situations.
Thank you, Jeff. And John, your thoughts on setup for automation?
Yeah, well, I mean, for us, it's always been clear that the lengthiest part of setup is actually measurement and adjustment after the first part is produced. So we just try to do everything we can to eliminate any variability that might be introduced from run to run. And, we've gotten pretty good with robotic welding. But all of our fixtures are doweled. We use blue code tables throughout the operation. So everything's in the same place when it goes back in the cell. And the pin table repeatability on the press brake cobots is really helpful too. We don't want operators having to engineer the process while the machine sits.
And that kind of leads into our next discussion here. Jeff, you were on a panel just this morning on designing for manufacturing, and I'd like to bring automation into that process, designing for automation. I think that would be part of the design for manufacture process. What processes you have and how you might be able to design a part better to make a part better, and having automation as part of that equation. Can you talk a little bit about bringing automation into design for manufacture?
Sure. Design for manufacturing, you're working with your customers on your design. We always try to implement a poke yoke into the design so that it goes together smoothly. You're never going to produce a bad part. It only fits one way. And if we have the volume of it, we look at the automation side of it as well and say, how can we do this where we've got ear clamps going in so that a part gets loaded by, let's say, a cobot, ear clamps come in and snap it, locks it right in a position. So you're always lined up in exactly where you're supposed to be. Looking at different types of materials. Somebody had brought up about welding galvanized. I believe that was John. Looking at those types of things ahead of time of where we can improve ourselves in the quoting stage and then in the production. Then we have CPI teams, so continuous process improvement, that'll identify different items that can be improved upon, whether it's a safety issue. Those we take as a high priority. More of a longer issue is, getting into productivity. We actually go with safety quality first. Then we go into the productivity side of it. So during the design stage, you can work with your customers to put things together with tabs, location, reduce the amount of welds, reduce the amount of fastenings, hardwares, and things like that. So it's very much a key aspect of what we do.
Hey, John, would you like to comment on that, designing for automation?
Yeah, I mean, one of the big things we run into in welded assemblies, different customers have different approaches to tolerance stack out, but a lot of times we find gaps designed into a product because the customer doesn't really understand the repeatability of a laser, say. And so when you've got a big gap at nominal and any variation at all, that can be a problem for a robot. So that's one of the first things that we do is just go through the model, identify any gaps, and close them up. I mean, that's had a huge impact in our success with welding.
Okay. And Stu?
Yeah, I'm going to echo what John said there. Tolerance stack up is huge. Going into any automated system, you have to have good parts, good material. We've had issues with, really hard materials that come out of the laser and start to bow or things like that. So it even gets down into like grain structure, grain direction of parts. The more consistent you are, coming into the automated system, the better off you're going to control those parts, especially in a welding operation where a lot of components are coming together. And we usually have to tighten up tolerances on like locating holes for pins and things like that. You may have to machine a certain feature because you need that tight of a tolerance for the automated system, and then that's going to increase, potentially your cost. And so you need to have those discussions up front, with the customer and make sure that, you're having those design reviews, and you want to get involved with those as early as you can. The farther down the road they get with the design, the harder it is to make those changes. So it's critical to get, your engineers talking to their engineers right at the beginning.
Sure. Yeah, automation, if you're a company that can make lousy parts more efficiently and quicker, that's probably not a long-term strategy, I wouldn't think. So you really have to pay attention to that up front. And, maybe if we could go around the horn too, maybe one or two things about your automation solutions, maybe an example, maybe something you didn't expect, something you didn't plan for, that it wasn't until you had an automation process in place, maybe as a kind of like a cautionary tale or something that other fabricators and stampers out there can think about. Maybe we'd start with you, John. I see you.
Well, you mentioned expensive boondoggle in your opening paragraph, and we do a lot of assembly, and have done a fair amount of automation in that area. But our first big venture was with it's a big clamp that part runs through a progressive die, and then it's tightened up around a tube with 4 5/8-inch carriage bolts. And our production volumes just started exploding on this thing. Couldn't hire people fast enough to put them together, so we hired an outside integrator to design an assembly cell. And I can actually still see it from my office, but basically it's just inventory of 3 Scara robots and a dial table and some parts feeders. Because what we didn't do was really evaluate the quality of the hardware inputs that we could only actually source from a few suppliers in China, and really evaluate their suitability for automation. So as it turned out, the additional automation that we would have had to add to qualify the hardware and make sure that it would assemble was going to cost more than the cell. And the other thing we didn't do when we leapt to an automation solution is we hadn't fully optimized the manual assembly process. So about 4 more iterations of that process. One person can complete as many parts in an hour as manually as the automated solution can complete. So it just, be really confident that you've considered all the inputs and that a thing really is suitable for automation. And I would say, the best process is usually the best process, whether it's automated or not. And sometimes I think spending time optimizing a manual process can probably save you some money.
Sure. And Jeff, a cautionary tale or maybe one advantage you found out about after the fact?
Yeah,
I think John hit it right on the head. To look at it ahead of time, make sure that you have the right volumes, the right processes, the right automation is being implemented. I've seen a few companies that have gone overboard on the automation and never paid off for it, for that option or that product. So to really look at it and make sure that you've got a good contract in place, that it's going to be a multi-year program where you can get your return on your investment is huge.
Sure. Not just automation for the sake of automation.
Exactly.
Great. Okay. And Stu?
Yeah, we were kind of set on automating a PEM insertion part, and similar to what John was talking about, we found through working with a lot of vendors that the tolerances on those PEMs and the hole requirement, you only had about 2 thousandths of clearance there. There really wasn't any automated or integrators that would touch the tolerancing required. They just couldn't locate. It was such a small piece. They couldn't locate that reliably over and over again with automation. We went through a lot of testing on that. And we ended up just throwing in the towel on that particular project. And like John said, just optimized we bought some new PEM machines. We optimized the manual process, and that was just a better way to go at the end. So sometimes I think you got to just cut your losses.
We have quite a few parts like that, and just people inserting hundreds of pins in sort of a slit fit hole.
Yep.
And robots can do it, but at a fraction of the speed that a person can do it. It
Right.
takes so much time to sense it, and then that it's definitely not there yet.
Okay.
Yeah.
And with between like automate, fab tech, these things, it's just amazing the advances in automation. Things like we talked about cobots, briefly touched on AMRs. We see vision technology for inspection, for part picking, for things like that. Really, anybody, you do well to walk around automate, walk around fab tech, see some of this. I mean, cobots have just exploded, AMRs, the vision technology, like we talked about, just so much out there. And maybe just in conclusion here, we're running up against it. Maybe start with John. Maybe the most fascinating, helpful automation thing. You don't have to name brands, but just some of the technology. What seems to be the latest and greatest type of technology you're seeing these days?
Well, our focus now is really more on the whole system.
Mhm.
So it's integrating everything into our ERP/MES system, because we know that we have the opportunity to see everything that's happening in real time, and then hopefully create some AI agents who can make intelligent adjustments in real time and keep everything moving. But as far as just hard assets that I want to buy, Stuart already has one that Trump Laser Center 7030. Laser cutting without slats, which seem to create most of the problems we run into. So that's inexpensive, but really, really interesting idea for me.
John, I'm really glad you brought up integration and the ability to bring these systems together, but because that's one of the gee whiz technologies that I see too. The software, the integration capabilities, the ability to tie these systems together. So you put it all together, it works, and you could have a whole I mean, just seeing some of these automated, lights out systems and these capabilities, it's just amazing.
But, getting those signals to a human operator with the same level of quality needed to drive a fully automated system also has a huge impact on results at the end of the day.
Well, I think we're right up against it now. I appreciate the panel taking the time, John, Jeff, and Stu. Great information here. And again, I appreciate talking to us. And I hope our audience out there got learned a little bit more about automation. So thank you. And over to you, Brad.
Yes, sir. Yeah, all the panelists, thank you so much for spending time with us today. Lou, you did a great job moderating. I know there's a whole lot more we can talk about when it comes to automation. But out of respect for our attendees' time and schedules, we are going to end it here today. But thank you for attending the program today, all the attendees. We do hope everyone found it to be a valuable experience. And we hope you'll join us tomorrow for session 2, which will feature 2 panel discussions on Industry 4.0, smart manufacturing, and AI for fabrication, which is a topic John just mentioned. So once again, an archive of the programs today will be available on our website soon. We'll send you an email with links to access those, and you can review again what you learned today and share the information with others in your companies. So again, thanks to our panelists, to Lou and Kate today for moderating, and to our attendees, and of course, always our sponsors as well. Hope everyone has a great afternoon, and we will see you all tomorrow.
Thank you.
Hello. Thanks, Brad.
Hello.